Oh, every time. Every time. Lights up. Welcome to 6.1 homework help. Welcome to geometry. So the first 6 problems, it says, for each of the following right triangles, determine the measure of the missing side. Leave the measures in the exact form if irrational. Okay, so that means don't convert stuff to a decimal. So leave it as a fraction, leave it as a square root, don't convert it to a decimal. All right. So we're using the Pythagorean theorem. Hold on. Sorry, I'm back. Actually, would it help if I color code? Okay, it does not matter which side is A, which side is B. The only thing that matters is your C, that's your longest side. That's your hypotenuse. That's your longest side. Hypotenuse. Hypot. Hold on, it's bad. Hypotenuse. Right, hypotenuse. That's your longest side. Your slanted, well, yeah. Okay. Anyways, so we're trying to find C, and then it doesn't matter when you make A and B. I'll make A be purple, maybe if it shows up. Okay, and let's make this 3. It doesn't matter. If you want to make this B instead, it doesn't matter. Let's make this one orange. Does that show up? Yeah. Okay. A squared plus B squared equals C squared. So we're just going to fill in this formula. We're trying to find C. Oh, I didn't label C. That would help. This is C. Okay. This is the Pythagorean theorem. Ooh, I have to give people extra credit. Okay, I'm not going to forget. So we're going to substitute 3 in for A. So it's 3 squared plus B squared, which is 4 squared, equals C squared, which is what we're trying to figure out. Okay, so we substitute in. 3 went in for A, 4 went in for B. That's all I did. Now let's start solving this thing. 3 squared, that's 3 times 3, that's 9. Plus 4 squared, 4 times 4, 16. Okay, equals C squared. So, well, I'll rewrite it one more time. Equals C squared. All right. 9 plus 16, I'm going to quit color coding. 9 plus 16 is 25. Okay. 25 equals C squared. Well, we're trying to find C, right? Our numbers weren't 9 and 16, they were 3 and 4. So we need to find C, not C squared. C squared is 25. Well, that's great. I'm trying to figure out what regular old C is. Okay, so the way you do it algebraically is you're going to, take the square root of both sides. Square root, okay? The square root of 25. So that means what number times itself is 25? So like 9, the square root of 9 is 3. 3 times 3 is 9. The square root of 16, 4, because 4 times 4 is 16. So what number times itself gives me 25? 5. So you get 5 equals, and then you're taking the square root, these cancel each other out. C squared, the square root, these cancel. So you're just left with C. Oh. So this is equal to 5. All right, so that would be your answer for number 1. Okay, let me do number 3. So number 2, you're doing the same thing as number 1. You're trying to find the hypotenuse, the longest side. You were trying to find C. All right, oh, let me rewrite my theorem. Ow, a squared. Okay, this is b, and then a squared plus b squared equals c squared. Okay. This time, we know our hypotenuse. We know our hypotenuse. We know C. This is C. Okay, C. So C is 4. So I'm going to go ahead and substitute that in. And then, it doesn't matter. Let me see if they actually, no, it doesn't matter. So this could be A or B. This could be A or B. I'm going to make this be A. So we're going to try and find B. So this is A. And we don't know what B is. Okay. So A squared is 1. So I'm going to substitute 1 in for A. So that's 1 squared plus B squared. Right, so I substituted my 1 for A, and I substituted my 4 for C. I don't know B. All right, here we go. 1 squared is 1 times 1, so that's 1 plus 4 times 4, sorry, 4 squared, which is 4 times 4, which is 16. Okay, we're solving for B squared. Well, we're solving for B, so we want to get this by itself. We want to get this alone. So I'm going to subtract 1. Okay, I'm going to stop color coding. So this is gone. Oh, almost. I'll keep color coding with B. B squared equals 16 minus 1, which is 15. Are you with me? I subtracted 1 from both sides because I wanted B squared to be alone. 16 minus 1 is 15. So now B squared is 15. I need to know what B is. So just like with number 1, you're taking the square root of both sides. Okay. The square root and the square cancel each other out. So you're left with B equals, and then this is what they mean when, what they say? Leave the measures in exact form if irrational. The square root of 15 is like, I don't know, it's 4 point some never-ending decimal. All right, so it's irrational. So we just leave it the square root of 15. Okay. So that would be your answer for number 3. Do not change this into a decimal, just leave it. Alrighty, I'm going to do number 4, and then I'll leave you alone for the rest of these. Feel free to skip this part if you're comfortable with these. So, I keep erasing it. Jeez. A squared plus there. So, what do we know? Looking at our triangle, what do we know? Do we know A and B, B and C? What do we, I guess I should ask, what are we missing? Okay. This is your hypotenuse. So this is C. So you know C. So I'm going to fill that in. So C is the square root of 10, and that is squared. All right, substitute square root of 10 in for C. And then this is where you can kind of pick and choose. I'm going to say this is A, and I'm going to say this is B. You could do it the other way around if you want. So I'm trying to find A. So I don't know A squared. So put that in. But then I do know B. B is 3. So I'm going to substitute 3 in for B. Right. So now we're solving for A squared. So A squared plus 3 squared. What's 3 squared? That means 3 times 3. 3 times 3, which is 9, equals the square root of 10 squared. Remember, these just cancel each other out. So you're left with 10. We're trying to solve for A squared, so you need to get this by itself. So we're going to subtract 9. Okay, I'm going to stop color coding as soon as I write this. So A squared equals, this is gone. So you have 10 minus 9, which is 1. Oh well. So A squared equals 1. That's all well and good. I need to know what A is. So we take the square root of both sides. These cancel, so you're left with A equals the square root of 1. So that would be your answer for number 4. Okay, number 7. You have to do 3 different things. So this is what you're given. You're given point A. All right. So first thing I like to do is make sure I understand my graph. So what is the coordinate of point A? Where is point A? What is the coordinate point for A? I go over here. Can you see me? Oh yeah. It's at 1, 2, 3, 4 over 4 and 1. So it's at 4, 1. We're gonna know that. So the first thing you have to do is rotate point A around the origin. So this is the origin. 90 degrees clockwise. All right. So clockwise, it's like the ticking of a clock, right? So we're going that way. Okay. There is a formula, not really a formula. There's a trick you can use. Formula, I don't know what to call it. But let's do it how we did in class. Okay, I will do it in purple. So we're going to rotate this point around the origin. Okay, so this is our rotating point. We're rotating around this point. Just like when we were rotating the lizard in class, we had a rotating point. So we're rotating everything 90 degrees around this point. So your first step is to connect your rotating point to point A. So I'm rotating around this point, so I'm going to draw a line and connect them. Hopefully without smearing too many things. That's pretty good. Okay. There. Smeared it a little bit. All right. Then, this is where you need to have your protractor. Unless you, oh, here it is. 90 degrees. So, the little hole on your protractor, put that over your rotating point. And see this line that's along my protractor? Can you see it? Make sure that lines up on the line we just drew. So the hole goes on the point, and then make sure you line up your line. Oh, I have it upside down. That would help. So there's my hole. There's that. And then 90 degrees. Oh dear. And then obviously my graph is way bigger, but it doesn't really matter. 90 degrees. Can we see this at all? Hold on, I'm going to look at you. Not really a good way I can zoom in though. 90 degrees is right here. That's where 90 degrees is on my protractor. Okay, so make sure it's lined up. So it's like right there. Hey, there. So then we're going to draw another line that follows that 90-degree angle. Okay. So now I made a 90-degree angle. This is 90 degrees here. Alrighty. We did that. Now, the last thing you have to remember is that the distance stays the same. So this point is how far away from here. You can measure with your ruler, or you can just count. It's 1, 2, 3, 4, right? It's 4 away, so that means this one's going to be also 4 away. 1, 2, 3, 4. So my point should be right there. And they said to label this A1, so this is A, or A, whatever you want to call it. Okay, hold on, because I'm going to tell you the trick. Okay, so here's the rule. If we're rotating, clockwise, 90 degrees, that would be important. 90 degrees clockwise, which is what we just did. We rotated this point 90 degrees clockwise around the origin. So some of you were kind of getting at this today in class, which is why I'm going to tell it to you, remind you what this is. So when you start with the point, which is at 4, 1, and if you rotate it 90 degrees clockwise, it has to be 90 degrees clockwise around the origin. 90 degrees clockwise around the origin. This is how your point changes, right? Our point started out as 4, 1. Our point became 1, negative 4. That's our new point. 1, negative 4. So that's what happens. Your y value becomes your x value. Your y value becomes your x value. Your y value becomes your x value. And then these switch and it becomes negative. If you don't understand this, it's okay. We will get into this later on in the chapter. For those of you that were hinting at it today, here's the rule for 90 degrees clockwise. There are rules for if I were to go the other way 90 degrees, there's a rule for that. If I were to go 180 degrees, there's a rule for that. But we'll start out with just this guy. Actually, you could probably figure out the other rules if you wanted to, based on this one. But anyways, that's the rule. So it's also a way to double check. So my y value becomes my x value, and then my x value becomes negative, and it's now my y value. So that goes there and becomes negative, and then these just, yeah, and then that goes over there. Okay, anyways. Okay, and then B, we have to reflect, oh wait, no. Oh yeah, we have to reflect point A over the x-axis and label as, I don't know what to call that, A with the 2 slash, I can't think of the name right now. So we're going to rotate, no, sorry. We're going to reflect point A across the x-axis. Okay. That's actually pretty easy peasy. Our lizard today was harder, but Kevin was right when he said in class they're just mirrors of each other. So if I'm reflecting this point, over the x-axis, basically you're just like flipping it over the x-axis. So right now this point is 4, 1. So I'm going to flip it over the x-axis, and so it becomes, should be like right there. So this is 4, 1, I'll write it here, 4, 1. This now becomes 4, negative 1. Okay. These are reflected over the x-axis. They're both the same distance. This is 1 away, and this is 1 away. Okay, we just reflected them. Okay, that's that one. The last thing you have to do, apply the rule. Oh, let me write this one down. So it says apply the rule x minus 2, y minus 5. We'll go, actually, it's fine, we'll go over here. X minus 2. How do they write it? Oh, good. And y minus 5. Okay, apply the rule x minus 2, y minus 5 to point A. We're dealing with point A. Oh, I didn't label this guy. Sorry. This is my... There. So just do what it says. So my point is 4, 1. I have to go, so it's going to be 4 minus 2. So that's what my x is. And then my y is 1. 1 minus 5. Okay, so what is that new point? Take your x, it's 4, so 4 minus 2, and that is 2. And then y minus 5. So my y point is 1, so 1 minus 5 is negative 4. So my new point should be at 2, negative 4. 1, 2, negative 4. 1, 2, 3, 4. Oh, it should be right next to this guy. Oh, different color. Hopefully that's what I was supposed to label it. Yep. So there you go. That is how you do number 7. Before I stop, I'm going to show you how. Hold on. Okay. This is going to help you out on number 8. So on number 8, you're asked to rotate 180 degrees about the origin. So I'm going to do that on number 7. So it's not going to be the right answer, but it's going to be how you do it for number 8. So here's how you rotate 180 degrees around the origin. Are you ready? Here's how you do it. Okay. So first of all, you would draw a line. We can ignore this line. You can draw a line from your point of rotation, your rotating point, which is the origin. Okay, I'm going to rotate this point 180 degrees. So just like we did when we were rotating at 90, connect these two at the point. Let me get rid of this guy. But this time we're rotating it 180 degrees. So same thing, put your little dot, sorry, your little circle, whatever. Make sure your lines line up. And then we're going 180 degrees, which is just this line right here. This line is 180 degrees. So that's like, kind of like that. Okay. Spin the line. So this is going to work for me. Spin the line. Hold on, sorry. Line them up. Okay, that's all I get. Go, 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 go. Okay. There. So 180 degrees is just a straight line. Well, I shouldn't say a straight line. No, it is a straight line. It's just a straight line. So this is at 180 degrees. So then equal distance, right? So this one is, we already determined 4 away, 1, 2, 3, 4. So this one is also going to be 4 away, 1, 2, 3, 4. So it should be, so it's 4 away from the origin, but it's on my line, so it's right here. And that is at the point, this is -4, -1. So that's what happens when you rotate 180 degrees. They just both become negative. Or, sorry, the signs just switch. The signs switch, so they become the opposite. So instead of +4, +1, I have -4, -1. Okay? So you're going to use what I just did, and that's how you're going to do, what is that, B? Number 8B. Except you'll have a different point because it's a different problem. But that's how you would do it. Okay, the last part of the homework, you're just graphing and comparing. So for instance, you're going to graph number 9 and number 10. And then number 11 says, like, what are the similarities and differences? So you're looking at, okay, do they have the same slope? Do they have the same y-intercept? Are their y-intercepts opposite of each other? You're just comparing them. So similarities and differences. Okay. That's what you're going to do for 9 through 17. I shall leave you there.